Here on this DeBacco University video, I'm going to look at a carbon dioxide controller that does not have fuzzy logic and provide you with some details about this style of CO2 controller. All right, let's look at a carbon dioxide controller without fuzzy logic for cannabis production. So first off, what would these be used for? And while they can be used with bottle systems, they're probably best utilized for carbon dioxide generators. Because even if your controller does have fuzzy logic, which I'll mention here at the end, it needs to be turned off if you're using a generator, as this will not work with this type of CO2 generation. Only bottle-based systems should be utilizing fuzzy logic. So here we can see the generator is an on-off system. Bottle systems allow for pulse dosing, which you cannot use with a generator system. There's different forms of generator systems. You can see here we have an unvented here, and here we have one in a greenhouse setting. So when we're looking at these controllers, they are set up much in the way that ones would be with fuzzy logic, in the sense that you would set a deadband. And what's a deadband? Well, this setting decides how tight you want the controller to keep the carbon dioxide levels to the target set point. Essentially, how far the controller will allow carbon dioxide levels to deviate from your chosen setting before targeting your carbon dioxide source to switch on or off. Most controllers default around 50 parts per million, but you may want to increase this to 100 parts per million for a generator system, as it will naturally fluctuate the levels more than a bottle-based system. Selecting 100 parts per million as your deadband setting will allow the gross base levels to be essentially over or under by 100 parts per million before the controller will turn on or off the generator. Now we'll notice the controller over here next to me has a deadband setting set to 25. This would be a little tight to run for a generator because it's going to have a lot more ons and off cycles, which could add unnecessary wear and tear to your generator. When in doubt, start with 50 and you can regulate from there. Going as low as 25 is possible, but it might see your generator running on and off with greater frequency. So make sure on the sensors of your controller that there is a presence of a photocell. We see that here, we see that labeled right here, and we see that here as well. This will help ensure that CO2 is only added during the light period, which is only when the plant can actually utilize it. A timer could be used if you have a regimented light schedule, but the photocell is a great fail-safe option to ensure carbon dioxide is only added when the plants can actually use it. A lot of growers, some controllers had growers try to dial in the times of lights on, lights off period, but the photocell is great for kind of forgetting about the exact timer setting in case timers were a little off. Also, if you're growing in a high tunnel or greenhouse environment, this can also allow the controller to automatically adjust to seasonal changes in duration of sunlight or photoperiod. Now, what is this fuzzy logic that you'd be missing out on? Well, keep in mind that fuzzy logic can maximize a growing cycle with bottle-based systems, and what it simply does is it allows for continuous adjustment and to automatically ensure efficiency. The reason why this can be used with bottle-based systems is the controller will automatically adjust the frequency and duration of its pulse dosing. This is not possible with generators because they need to be on or off. So just keep that in mind that if you are looking at potentially going into using a generator for now, but looking at a bottle system down the road, make sure you get one with fuzzy logic so the fuzzy logic can be utilized when you're using the bottle-based system, but make sure that fuzzy logic is off or you get a controller that does not have fuzzy logic if you're only going to be using a generated source of carbon dioxide.